question, there is a concrete beam whose cross-sectional width that is 230 and the effective depth is 400 mm. So here given B equals to 230 mm and effective depth that is D equal to 400 mm, and also given that is maximum shear force that is VU equal to 120 kilonewton, which is equals to 120 into 10 to the power 3 Newton. Okay, and the grade of concrete used that is M20, and main steel bar used that is Fe415, and the stirrup used that is F250. Okay, or given that design shear stress that is tau C is given 0.48 Newton per mm square. Okay, for this we need to calculate the spacing between the stirrups. Okay, for calculating the spacing between the stirrups, before calculating, so we need to calculate that the nominal shear stress that is equal to tau V equal to VU upon BD. VU here that is 120 into 10 to the power 3. B is 230 and D is 400, which gives the value of 1.3 Newton per mm square. As you can see that the tau value is greater than tau C, which is our design shear stress. So we need to go for the shear reinforcement design. Here shear reinforcement design is necessary. For the extra shear developed in the section, that is 1.3 minus 0.48, that is about 0.82 Newton per mm square. For this amount of shear stress developed in the section, we need to provide the vertical shear stirrups. Okay, for this the shear force resisted by the vertical stirrups, that is VUS, is equals to tau V minus tau C into BD. Tau V minus tau C, that is 1.3 minus 0.48 whole into B 230 and 400, which is equals to okay, 75.44 kilonewton. Okay, then again we are going for the calculation of the area of stirrup used in the problem, that is ASV. We know that there is a two-legged 8 mm stirrups of Fe250 used, so the area becomes 2 into 5 by 4 into 8 mm are used, so 8 square of 8, that is equals to 32 pi, which is near about 100.53 mm square. So for this area, we need to calculate the spacing between the bars. Here the two-legged 8 mm dia stirrups are used So the spacing SV equal to, we know that the formula that is 0.87 Fy ASV D by VUS. So we can put the value that is 0.87. Fy is, there is used stirrups, that is Fe 250. So the Fy becomes 250 and ASB become 100.53 and D is given, that is 400, or VUS is given, is calculated, that is 75.44, which gives you out a value of 115 mm. Okay. So for providing the spacing that is 115 mm, we need to check the is our spacing is correct as per our codal provision. So we know that the spacing, according to the codal provision, spacing should not be exceeded for, that is 0.75 D. For vertical stirrup, that is 0.75 into D, that is 400, which gives out a value of 300 mm. And this condition is also satisfied. And the second, that is for minimum reinforcement, the spacing SB should be less than or equal to 0.87 Fy ASV by 0.4 B, which gives out a value that is 0.87 into Fy, that is 250, and ASP, that is 100.53 upon 0.4 into B, that is 230, which gives out a value that is 237.66. So our spacing must be less than the 237.66, and another spacing given according to codal provision, that the spacing must be less than 300 mm, and our calculated value, that is 115 mm. So here we must provide it to at a spacing of 115 mm between the vertical stirrups. This spacing should be the center to center spacing. Okay. Thank you.